Now that we've looked at solving linear equalities, let's look at some graphical inequalities. Here is a typical graphical inequality question. It's asking us to solve the inequality x is less than 4 graphically. And what that means is that on our axes here, what area of the axis will the x-coordinate be less than 4? To solve this, you always do the same. The first thing you do is draw the line x equals 4. So notice that I've changed the inequality sign to an equal sign. For any question, you always just draw the line. So let's get out our ruler. We know that if x equals 4, if that's our graph, then the x-axis will be 4 at all points, which means it's going to be a vertical line at 4. Before we draw the line, notice that it's a strictly less than inequality. Like we leave the circle unshaded on the number line, we're going to draw a dotted line down, like this. So here's our line, x equals 4. Now we need to find the area in which the x-coordinate is always going to be less than 4. So the secret is to pick a point on the axis and see if it fits. So the common one is always to use 0, 0. So basically, when x is 0 less than 4? Well, yes, 0 is less than 4, which means that the point 0, 0 lies in this area we're trying to find. And because it lies in this area, and that's to the left of this line, we know that the area we're looking for is everything to the left of the line x equals 4, because any points in this area will have an x-coordinate less than 4. And that's how we do the first one. Now that is confusing, so keep watching and you're going to see common themes showing up to help you understand it. Have a look at the next question. We need to shade the region where y is greater than or equal to -2. First thing we need to do is draw the line y equals -2, because we forget about the inequality sign for now. So let's get out our ruler, we move it down to -2 over here, because along this line where my ruler is, the y-coordinate will always be -2. And because we're using a less than or equal to sign, we do a fully shaded in line. There's no dots, it's just a normal block line. Now that we've done that, we need to ask ourselves which region is the region we're looking for. So again, let's use the origin 0, 0 as our indicator to whether the region will be above this line or below this line. At the point 0, 0, we need to ask ourselves, is 0, when y is 0, greater than or equal to -2? Well, the answer is yes, 0 is greater than -2, which means that this point lies in our region. And so we know that the region we're looking for is everything above the line y equals -2. Finally, we're going to combine y and x. So we need to solve y is greater than or equal to 3x minus 1 graphically. So the first thing we do is we draw the equation y equals 3x minus 1. Now you should know how to do this. We know that the y-intercept, this number here, is at -1. And then because of the gradient is 3, we're going to go 1 along and 3 up. So here are 2 points. And now with our ruler, we can join them up. Now before we start, are we going to be using a dotted line or a straight line? Well, because we have a less than or equal to sign, we're going to do a straight line down. Now the question is our region to the right of this curve or to the left of this curve? Well, again, let's use the origin to find out. So at 0, 0, we need to ask ourselves, well, when y is 0, is that greater than or equal to 3 lots of 0, because x is also 0, minus 1. Notice I've just changed y and x for 0. Well, we know that 0 will be then greater than or equal to 3 times 0 is 0, so we can forget it, minus 1. 0 is greater than or equal to minus 1, which means that this lies in our region, which means that the region we're looking for is everything to the left of this line. So that's how you solve graphical inequalities. You just have to draw the line and then find whether you're looking to the region to the left or to the right of that line. In the next video, we're going to look at multiple graphical inequalities to get more specific regions.